simple example of a linear equation. And the only reason I want to do this simple one is to get rid of some of the mistakes that are commonly made. Number one, you cannot subtract 4 minus 2 to begin with. The operation connecting the 2 to the x minus 3 is multiplication, so that has to happen first. So pretty much a general rule with linear equations is get rid of parentheses, loosen up all these terms. So the first thing we're going to deal with is this negative 2. We're going to distribute it over the two terms of the polynomial. And then also we're going to distribute this positive 3 to these two terms. So we're going to get 4 minus, that's a negative 2 times x, so that'll be a negative 2x. This is a negative 2 times a negative 3, which will give you a positive 6, is equal to, here we'll have 3 times x, and then 3 times 2 is a positive 6 again, and we'll have a plus 1 sticking off there at the end. Now after you get rid of parentheses, the best thing to do is to simplify your expression. So here we have a 4 and a positive 6, so that's better known as 10. So we'll have 10 minus 2x on this side. On the other side we have this 6 and this plus 1, so we'll have this 3x plus 7. Now once you get all the terms separated, nice on line, no fractions, your next step is to get the variable you're solving for on the same side of the equation. Here we have an x on the left and an x on the right. We need them to be on the same side. Now technically it doesn't matter which one you move, but I usually move the smaller of the two. So what I'm going to do to move it over is, since it's a minus 2, I'm going to add 2x to both sides. Now, what property allows me to do this? Well, there's actually two of them that are coming into play. This here, the negative 2x and the positive 2x, that's called additive inverse. The other property that's coming into play is one that is considered the additive property of equality. If you add the same thing to both sides of an equation, it doesn't change anything. So here we get a big fat 0, so technically, and I know you're all going to say cancel it out, but technically this is really 10 plus 0 is equal to 5x plus 7. Now, the canceling thing is just to get rid of this little language here that, 10 plus 0 is just plain old 10. So when you say the word cancel, it's a shortcut, but it's a very dangerous one sometimes, so you really want to make sure you know what's really going on. So that leaves us a 5x plus 7 on that side. Now, the second step is, after you get the variables on the same side that you're trying to solve for, you try to get all the other junk to the other side. Well, that junk that's next to this x is that 7. That's the easiest one to move. We could move the 5, but it causes a lot of difficulties. So we'll move the 7, and we're going to use again the additive inverse. So the opposite of plus 7 is minus 7. Now if you subtract 7 from the right hand side, you have to subtract 7 from the left hand side. Alright, so now we're down to 3 is equal to, and technically they don't cancel out, positive 7 minus 7 is really 0. Of course 5x plus 0 is just 5x. It's that additive inverse property. Alright, now to get rid of the 5, a lot of you are just going to say, oh, just divide by 5. Well, what if I took that away from you? What if you were forced to deal with the 5 with multiplication? Because the operation connecting these two is multiplication. So what times 5 is going to create the multiplicative inverse of 1? So what we can do is use what's called the multiplicative inverse of 5, which would be 1/5. So I'm going to multiply both sides by 1/5. Again, this is the multiplicative property of equality with equations. Now, the 5 times the 1/5 we can do, commutative property and all that fun stuff. And 5 times 1/5 is 1. So on the left-hand side, we're going to get 3 times 1/5, better known as 3/5. And on the right-hand side, we're going to get 1 times x, better known as x. Now, a lot of people don't like leaving equations sitting in this order, so it is legal to turn it around. X equals 3/5. It's called the reflexive property of equality. And there's your solution. Now technically you should be able to take this and plug it back into the beginning and just make sure that both sides are equal, but not many people are going to plug in a fraction. And we're done.